Alright, this is the prelab for mystery solutions. Basically, all we're doing is writing net ionic equations. Alright, and so I will go through this with you. Starting, you're going to have 6 solutions that we don't know which is which, but we can figure it out by testing them with each other and comparing them to how they react. So we're going to start with all the silver nitrate possible combinations. Silver nitrate and potassium hydroxide, the silver would recombine with hydroxide and the potassium with the nitrate. We know potassium would be not soluble, or would be soluble, so our silver hydroxide is what's going to be insoluble and will precipitate. So this guy will have a precipitation. The next one, silver nitrate and magnesium sulfate. Again, silver reacts with sulfate and will have a precipitate, and magnesium nitrate will be our spectator ions. So silver nitrate should produce a precipitate, or silver sulfate. The next one, silver nitrate and sodium phosphate. Silver will react with phosphate and precipitate, because most phosphates precipitate, and then sodium nitrate would be our spectator ions. The next one, silver nitrate plus barium chloride. Silver chloride will precipitate, and barium nitrate then will stay in solution. So again, a precipitate. And then silver nitrate and copper 2 chloride. Again, will form silver chloride and copper 2 nitrate, which will be in solution. So all 5 of the silvers should react. So if we get a solution that reacts with everything, we can be pretty confident that that is silver nitrate. Going on to the next 6, magnesium sulfate and potassium hydroxide. Magnesium hydroxide will form and potassium sulfate. Hydroxides are usually insoluble. The exceptions being, of course, PMS. No, not PMS isn't an exception. The exception here are the big alkaline earth metals. Barium sulfate will dissolve, calcium sulfate, and strontium sulfate. I had to look at the periodic table. So magnesium sulfate should precipitate. So this one should have a precipitate. Magnesium sulfate and silver nitrate. The magnesium will bond with the nitrate and it will be aqueous. And the silver will form a precipitate with our sulfate, so that will be have a precipitate. Magnesium sulfate with sodium phosphate. Phosphates almost always form precipitates, so again we should have a precipitate there. Magnesium sulfate and barium chloride. Barium sulfate should form a precipitate, because that would be, sulfates usually precipitate, the exceptions being PMS and the big 3 alkaline earth metals. Barium sulfate, and then we have magnesium chloride, which chlorides are usually will not precipitate. Finally, magnesium chloride and magnesium sulfate and copper 2 chloride. Magnesium will bond with the chlorine and that will stay in solution, and copper 2 sulfate will dissolve. So the magnesium row, we should have 5 compounds, or 5 reactions out of the 6. The third one, potassium hydroxide and magnesium sulfate. Potassium will bond with sulfate and it will be insoluble, or it will be soluble. Magnesium hydroxide We already said up in this reaction that magnesium hydroxide would precipitate. Oops, I don't know how I did that. So this guy should form. Potassium hydroxide and silver nitrate. Potassium nitrate will not form a precipitate, but silver hydroxide will. Potassium hydroxide and sodium sulfate, potassium phosphate, or sodium phosphate, potassium phosphate will not precipitate, and sodium hydroxide will not precipitate. So there'll be no precipitate in that reaction. Potassium chloride will not precipitate. It'll be soluble, and barium hydroxide is the exception in the hydroxides, so it should stay soluble. Potassium hydroxide and potassium chloride, of course, is soluble. Copper to hydroxide. Hydroxides are usually insoluble. So for that set, we should have 3 reactions and 2 that do not have a reaction. All right, the next page. And let me erase my ink. Sodium phosphate and magnesium sulfate. Sodium will bond with the sulfate. Sodiums are always soluble. Magnesium phosphate will precipitate. So that guy's going to have a precipitate. Silver phosphate and sodium phosphate and silver nitrate. Silver phosphate will always precipitate, and sodium nitrate will not. Sodium phosphate and potassium hydroxide. Sodium hydroxide will not precipitate. Potassium phosphate will not precipitate. So that will not have a precipitate, no reaction. Sodium chloride will not precipitate. Barium phosphate will, so we should have a reaction. Sodium phosphate and copper 2 chloride. Sodium chloride will dissolve in water. The copper 2 phosphate, though, will form a solid. So we should have 4. And we can look and see how that will be different from the last one that had 4. Next one, barium chloride and magnesium sulfide. Barium sulfate is one of the exceptions. Sulfates usually precipitate, but sulfates usually do not precipitate. Barium sulfate will, and then magnesium chloride will stay in solution. Barium chloride will form with the nitrate. That'll be aqueous. Silver chloride will precipitate. Barium will form with hydroxide. This is the exception to the rule on hydroxides, so it will not precipitate, and potassium chloride will not precipitate. So there'll be no reaction for that one. Barium phosphate will precipitate, because phosphates almost always do, and sodium chloride will be the spectator ions. Barium chloride will stay in solution, and copper 2 chloride, that they just switch places and nothing happens. Next, copper 2 chloride and magnesium sulfate. Copper 2 sulfate. Sulfates are almost always soluble. Magnesium chloride, soluble, except for PMS. Copper 2 chloride and silver nitrate. We'll get silver chloride, which will form a precipitate, and copper 2 nitrate, which will be aqueous. Copper 2 hydroxide will form a precipitate, and potassium chloride will be spectator. Copper 2 nitrate will precipitate, Sodium chloride will be aqueous. And again, these guys will just switch places, so there'll be no net reaction here. So I'll go back and mark my precipitates. Alright, so there's your prelab. You've marked the ones that will precipitate. You could go back and highlight them if you want to, but that will come in useful when we begin to build our case for which is which. Alright? The instructions are the same pretty much as the last time. You're going to clean off your laminated grid, a drop of solution in each square. Don't touch the dropper. On your report sheet, write only the reactions that occur. Leave the squares empty that don't occur because it's easier to see. Alright, that's it.